Hi guys, today we're going to be looking at probability. This is suitable for GCSE students. So getting straight into it, please like, share and subscribe. And we're just going to start. So question 1, it says the probability that a dice will land on a 5 is 0.3. Megan is going to roll the dice 400 times. Work out an estimate for this number of times the dice will land on 5. So first we know that a dice has 6 sides or 6 faces if you want, and you can only get 5 once. But right now you've been given the probability of a biased dice. So normally if you have an unbiased dice, the probability of getting a 5 will be 1 out of 6, okay, because it has 6 faces. So you only get one chance of getting a 5 when you throw the unbiased dice once. But because it's a biased dice, the probability of getting a 5 is 0.3. Now this is when you throw that die once, okay? So if you throw it once, you get 0.3, right? But if you're going to be throwing it 400 times, so times that by 400, right? Now it says work out an estimate. Because it says estimate, so they are not necessarily seeking for the actual value of 0.3 times 400. So you're going to be working with an estimate. So what we can do is reduce this by 10, increase this by 10, which it just basically means the same thing, to be honest. So 0.3 times 400 is the same thing as 0.3 times 40 times 10, because we know that 40 times 10 gives us 400, right? Now we're going to bring that 10 to work with this one. So 0.3 times 10, that is 3 times 40. So by estimate, 3 times 40 is equal to 120. Okay, so we expect to get 120 times. Now Jack sows 300 wildflower seeds. So that's the total number of seeds Jack has sown. The probability of a seed flowering is 0.7. So this is the probability of a seed. So one seed, the probability of it flowering is 0.7. Now work out an estimate for the number of these seeds that will flower. So I'm sorry that bit there is not clear, but it means it says flower. So if he sows 300 seeds, probability of getting one of them flowering is 0.7. So one of it is 0.7. Now if he throws in 300 lots of that, how many of those will flower? Okay, so again we're working by estimate, right? So 0.7 times 300 is the same as 10 times 30. So 0.7 times 10, that is 7 times 30. So we are expecting to get 210 flowers. Okay, that's our final answer there. Now question number 3. So I'm going to try and fit the whole thing into the page. Just bear with me 1 second. I'm sorry, I'm going to have to shrink that a little bit. Okay, so trying to fit everything in. Alright, so Angel Limited manufacture components for washing machines. The probability that a component will be made within a tolerance of 1/10 of a millimeter is 0.995. So I'm sorry, my printer did not print that clearly. So that number there is 0.995. Okay. So the probability that a component will be made within a tolerance of 1/10 of a millimeter is 0.995. So that's your probability there. Now, Angel Limited manufacture 10,000 components each day. Honestly, I'm not sure why my printer decides to skip words and numbers. So there is meant to be each day. So Angel Limited manufacture 10,000 components each day. Work out an estimate for the number of components that will not, so emphasis on will not, be within the tolerance of 1/10 of a millimeter each day. Now, the first thing we need to put in mind, okay, is that number there, 1/10 of a millimeter, right? Now, 1/10 of a millimeter, the probability that a component will be made within that tolerance is 0.995. Now, the probability that a component will not be made within that tolerance will be 1 minus that. So you need to remember that the probability of an event happening and not happening or not happening is 1, right? So the maximum probability that a person can get is 1, okay? So one event happening and the other not happening. So this is 0.995 happening, but not happening will be 1 minus 0.995. So that means that the probability of that the event will not be within that tolerance is 0.005. Okay, so now this then becomes the probability that we work with, okay, because that's the probability that a component will not be made within that tolerance of 1/10 of a millimeter. Okay, now so 0.005, right, is the probability that one component will not be made. Now they manufacture 10,000 components each day, so we want to know how many components will not be within that tolerance. Okay, and again we are working out an estimate. So this is 1, 2, 3. So that means that we want to have 10,000 is the same as 10 times 1,000. So we've got our 0.005 here, and 1,000 multiplying that makes that to become 5, then times by that 10. So that means that we will have 50 components that will not be within the tolerance of 1/10. Hopefully this makes sense, but not to worry, there are so many questions to go through in probability here. So by the time we get through to most of it, it should make more sense. So we're going on to question 4. Okay, just bear with me. Let me see if I can zoom in a little bit more. Hopefully we can see that. So question 4 says, 4 teams, City, Rovers, Town and United, play a competition to win a cup. Only one team can win the cup. The table below shows the probability of City or Rovers or Town winning the cup. Work out the value of X. So this is all 4 of them. Probability of City winning. So if only one of them can win, then that means that we have a probability of one winning and the others not winning. So probability of City winning is 0.38. Probability of Rovers winning is 0.27. Probability of Town is 0.15. So to get that of United, remember we said the total probability should always be equal to 1. So we're going to add all of this together and subtract from 1 to get that of United. So 0.38 for City plus 0.27 for Rovers plus 0.15 for Town. Okay, so if we add all of that together, camera is a bit blurry again, just bear with me 1 second. Okay, it's clearer now. So I have 3, 4, 5, 6, 7, 8, 0.80. Then 1 minus 0.80 will give us 0.20. So that there, our x should be 0.20. Okay, number 5. Mia spins a spinner. The spinner can land on red or green or blue or pink. The table shows each of the probabilities that the spinner will land on red or green or blue. So we want to find the probability that it will land on pink. So again, it's the same thing. The spinner could land on any one of them. So a maximum probability is 1 altogether. So we'll do the same thing we've done. Add all 3 together and then subtract that total from 1. So 0.4 plus 0.1 plus 0.2 is equal to 0.7. Then 1 subtract 0.7 will give us that for pink, so which is 0.3. In there, our answer should be 0.3. So everything should add up together to give you 1. Okay, for question 6. A bag contains some sweets. The flavors of the sweets are either strawberry or chocolate or mint or orange. Sarah is going to take one sweet at random from the bag. The table shows the probability that Sarah will take a strawberry sweet or a mint sweet or an orange sweet. Work out the probability that Sarah will take a chocolate sweet. So we've been given the probability of 3 flavors. So to work out the 4th one, we'll do the same as question 4 and 5, which is adding the ones we've been given together and subtract from 1. So strawberry 0.32 plus mint 0.17 plus orange 0.2. Those all together will give, that's 9, 0.69. Then 1 subtract 0.69. So chocolate should be 0.31. Alright, moving on swiftly to question 7. Okay, I'm just trying to get the focus of this. My camera is being too blurry for my liking. Okay, Question 7 says a bag contains only red, green, and blue counters. The table shows the probability that a counter chosen at random from the bag will be red or will be green. So we need to first find out the probability that it will be blue. So we'll do the same thing as what we did in question 4 to 6. So all of that should be a total of 1. So 0.5 plus 0.3, that gives us 0.8. Then to find that of blue, subtract it from 1. So 1 subtract 0.8, that gives us 0.2. Down here, you write 0.2. Now the question carries on to B. It says that the bag contains 50 counters. Work out how many green counters there are in the bag. So if the probability of picking one green is 0.3, okay, so how many greens will possibly be picked out of 50 counters? You just multiply that by 50 to get your frequency, or to get the number of green counters that will be there. So 0.3 times 50, that is 15. Okay, so there will be 15 green counters. Right, moving on to question 8. A bag contains counters which are blue or red or green or yellow. Mark takes a counter at random from the bag. The table shows the probabilities he takes a blue counter and a red counter or a yellow counter. So again, same as before, we need to figure out the green probability of picking a green counter. So we just add all three together. So 0.3 plus 0.2 plus 0.1, that should give us 0.6. So then to find that of the green, you just do subtract your 0.6 from 1, and that should give you 0.4. So our green is 0.4. Next it says, bear with me 1 second. Okay, Mark puts the counter back into the bag. So he picked a counter, right? Because Mark takes a green counter, but then he returns it back into the bag. Laura and takes a counter at random from the bag. She looks at its color, then puts the counter back into the bag. She does this 50 times. Okay, work out an estimate of the number of times Laura takes a red counter. So the probability of picking a red counter once is 0.2, right? So probability of picking a red counter once is 0.2. But every time she picks it, she returns it back into the bag, and she's done this 50 times. Okay, because it says it here 50 times. So 0.2 times 50, that is 10. So the number of times that Laura, an estimate, is likely to pick red will be 10 times. Okay, so moving on to question 9. Question 9 says Marco has a 4-sided spinner, so it has 1, 2, 3, 4 sides. The sides of the spinner are numbered 1, 2, 3, and 4. The spinner is biased, so always pay attention to that word biased or unbiased. Now, the meaning of the word biased is that it will favor one side more than the other. It's not even, it's not equal. It's just like when you have a normal dice, an unbiased dice, when you throw it, probability of landing on 1, 2, 3, 4, 5, 6 is the same. It's equal. So 1 out of 6. But when you have a biased dice or a biased spinner in this case, the probability of landing on one thing is more than the probability of landing on the other. So it's uneven. The table shows the probability that the spinner will land on each of the numbers 1, 2, and 3. Work out the probability that the spinner will land on the number 4. So we're going to be doing the same thing as we've done before. Add all three together. So 0.2 add 0.35 add 0.2, and that should give us 0.75. And then to find the probability of landing on a 4, subtract that from 1. So 1 subtract 0.75 should give you 0.25. Okay, now the question carries on to be there. Marco spins the spinner 100 times. Okay, so remember these probabilities that we have here. 1 second, 0.25. So these probabilities that we have here are the probabilities when the spinner is spun once. Okay, but right now Marco spins the spinner 100 times. Work out an estimate for the number of times the spinner will land on the number 2. So if he spins the spinner once, okay, it will land on the number 2. Probability of that happening is 0.35, right? But then if he spins the spinner 100 times, the number of times that will land on the number 2 will then be 0.35 times 100. That's 35. So expect it to land on number 2 35 times. Okay. Question 10a. A box contains bricks which are orange or blue or brown or yellow. Duncan is going to choose one brick at random from the box. The table shows each of the probabilities that Duncan will choose an orange brick or a brown brick or a yellow brick. So work out the probability that Duncan will choose a blue brick. So we've been given that of orange, brown and yellow. We're just going to do the same thing again. Add all three probabilities together. Okay, so if we add that together, 9 plus 5 plus 4 is 18. 3 plus 2 plus 1 is 6. Plus 1, 7. So 0.78. And then subtract that from 1. 0.22. Okay, so probability of picking a blue is 0.22. Now, the question 10 carries on. Oh no, it doesn't actually. So I think that's it for question 10. Okay. So moving on to question 11. That's a bit blurry. Let me see if I can. Okay, good. Ricky has a packet of flower seeds. The table shows each of the probabilities that a seed taken at random will grow into a flower that is pink or red or blue or yellow. So we want to work out the probability that a seed taken at random will grow into a white flower. So we do the same thing as before again. So add all of these 4 probabilities together, then subtract the 8 from 1. So 0.15, add 0.25, add 0.20, add 0.16, and that will give us a total. This gives us 0.4, 0.6, so this is 0.76, then 1 subtract 0.76, 0.24. So probability of a y is 0.24. Okay, so that question carries on. It says there are 300 seeds in the packet. Apologies, the printer has done its magic again by swallowing up some words. Okay, so that there should be packet. All of the seeds grow into flowers. Work out an estimate of the number of red flowers. So probability of red is 0.25, and out of 300 seeds, the probability of getting a red flower would just be 0.25 times 300. If you were to punch that into your calculator, we should be getting 75 red flowers. Okay. Question 12. There are only red counters, blue counters, white counters, and black counters in a bag. Red, blue, white, and black. The table shows probability that a counter taken at random from the bag will be red or blue. So we've not been given white or black. So those are blank. That there should be black. So once again, thanks to my printer for swallowing up some words. Just gonna write that out. So black, hopefully you can see that. The number of white counters in the bag is the same as the number of black counters in the bag. Tanya takes at random a counter from the bag. Work out the probability that Tanya takes a white counter. So first of all, we've been told that the number of white counters is the same as number of black counters. So whatever is here should be here. So first, we will add these two together and do the same thing by subtracting from 1. So 0.2 plus 0.5 is equal to 0.7. 1 minus 0.7 is equal to 0.3. So now, together, white and black together are 0.3. But we want to get just the white and just the black, and we've been told that they are the same, right? So number of black and white are the same. So all you need to do is to divide that 0.3, so you're sharing it between the white and black. So that means that if you split that into 2, 0.3 into 2 equal parts, we're trying to share it between white and black, we should be having 0.15. So that means that white is 0.15, black is 0.15. So if you were to add all of these probabilities together, it should add up to make 1. Okay, so B says there are 240 counters in the bag. Work out the number of red counters in the bag. So our focus is on red. Probability of getting a red when you pick 1 is 0.2. Probability of so trying to find how many reds then you will get out of 240, we're just multiplying, same as before. So that gives us 48, right? So we expect to get 48 red counters on the estimate. question 13. We're almost there. A bag contains some balls which are red or blue or green or black. Work out probability that Yvonne will take a green ball. So same thing again as before, add all of these together, subtract from 1. So the reason I'm going over the whole question is for those who struggle in probability. So yeah, the more questions that you try to answer, the better you become. Just basically practice makes perfect. Okay, so 0.3 plus 0.24, that's 0.54, and 0.54 plus that would be 0.71. And then we do 1 subtract 0.71. So that is 0.29. So probability of green is 0.29. Now on to question 14. Here is a 4-sided spinner. The spinner is again biased. So that means that one side or a few sides are favored over the other. The probability that the spinner will land on 2 is the same as probability that the spinner will land on 4. Okay, so work out the probability that the spinner will land on 4. So if it's the same, then we're doing exactly what we did on question 12. So add these two together. So 0.2 add 0.1 to give us 0.3. Then the probability that it will land on 2 and 4 are the same, right? So 1 subtract 0.3 is equal to 0.7. Now we want to split that 0.7 between 2 and 4. So you just divide that by 2. That should give us 0.35. So that then means that if you were to add all 4 of them together, it should make 1. Now Shania is going to spin the spinner 200 times. Work out an estimate for the number of times the spinner will land on 3. So if he spins the spinner once, 0.1 is the probability of it landing on 3. But if he spins it 200 times, then the number of times it will land on 3 will be 20 times. Okay, so on to question 15. Here is a 4-sided spinner again. The sides of the spinner are labeled 1, 2, 3, and 4. The spinner is biased. The probability that the spinner will land on each of the numbers 2 and 3 is given in the table. The probability that the spinner will land on 1 is equal to the probability that it will land on 4. So we're doing the same thing as before. We're trying to find the value of x. So 0. Oops, that's not clear. Sorry, there we are. 0.3 plus 0.2, that gives us 0.5. Now 1 subtract 0.5 is 0.5. Then we want to split that between 1 and 4 because they've said the probabilities are equal. So that means that 0.5 is divided by 2, and that gives us 0.25 Now work out an estimate for the number of times it will land on 2. And that is once Sarah spins the spinner 200 times. So if she spins the spinner once, the probability that it lands on 2 is 0.3. And the number of times it will land on 2, if she spins it 200 times, and we just got 20 times 3, it should land 60 times. Okay, on to question 16. So here is a 4-sided spinner. Oof. My printer really did me dirty on question 16. Pretty much all of the numbers have been eaten up. Okay, so I'm going to just bear with me. Let me quickly scribble in the numbers that are taken up. So here is 2, 3, and 4. So here says Sarah, and here says to work. On that little bit there is spinner. Okay, I think that will do. So here is a 4-sided spinner. The sides of the spinner are labeled 1, 2, 3, and 4. The spinner is biased, so the probability that the spinner will land on each of the numbers 2 and 3 is given in the table. Probability that the spinner will land on 1 is equal to the probability that it will land on 4. Sarah is going to spin the spinner, so that's meant to be 500 times. So she's going to spin it 500 times. Okay, work out an estimate for the number of times it will land on 4. So for us to work out the number of times that it will land on 4, first we need to at least know what the probability of it landing on 4 will be. Okay, so we'll do what we've done before, add these two together and subtract it from 1. So 0.46 add 0.28, and that will give us 0.74. Then 1 subtract 0.74, 0.26. Okay, now the probability of it landing on 1 and 4 are equal, so that means that they both share that 0.26. So 0.26 divided by 2 is 0.13. So probability of it landing on 4 is 0.13, and on 1 is 0.13. So if you were to add all of those together, it should make up into 1. Now, if Sarah spun the spinner 500 times, how many times will it land on 4? So probability of it landing on 4 once is 0.13, then 500 times of throwing it will be 65 times. So it will land on 4 65 times. Okay, so that brings us to the end of our first probability worksheet. Thanks for joining me on this. Like and subscribe, and please share this video, and I'll see you in the next one. Bye.